So previously, we managed to talk about the translation. We managed to work out the translation with some typical exam questions that we might be given, considering that a translation is an isometry. It lies under isometries where the figures are congruent. But we saw that at the end, when lines are being constructed, if you are joining those lines, you are going to have parallel lines of equal length. So on a reflection, it is still one and the same with these other three transformations, because I said the isometries, the congruence there, it is affecting three transformations. If you still remember, we said there are three: translation, all right, reflection, and rotation. These are the three transformations we are going to have. Of the three transformations, translation, reflection, rotation, these three transformations, the only property that we refer these three separately, I said it is because of the congruency. The object and the image are congruent figures. It's because of the congruent figures. The part of the isometries, they are isometries, these ones. So meaning to say that whenever a translation, whenever you think of a translation, you must be thinking of a reflection at the same time. You must be thinking of a rotation at the same time. It's because of the congruent figures. But on a translation being congruent, on a translation now, it has its own property which separates it from a reflection, which separates it from a rotation, which I said when we join now the corresponding points, we are going to have this time parallel lines. We are going to produce parallel lines of equal length. You are going to produce parallel lines of equal length. So this is the difference that we are going to have between a translation and a reflection. Because also on a reflection, being congruent as they were, but this time when you join, you are going to produce parallel lines, which is true. You're going to have parallel lines, but this time they are of an equal length. So that is how you conclude that this is a reflection. Parallel lines of an equal length. But these lines will be parallel. A rotation is totally different from this. We're going to talk about this, but a rotation, if lines are being drawn, they are going to cross each other like this. They are not parallel. No, they are going to cross each other at a certain point. That's a rotation. You know that this is a rotation. But these three, the major point which makes us to compare them is because of this, the figures being congruent, the object and the image being the same. The object and the is only the position that changed, not the size of the object. No, the size of the object and the image is the same. You think of a translation, you think of a rotation, you think of a reflection. So a rotation, if you join the points A to A1, B to B1, the lines will cross. A reflection, if you join A to A1, B to B1, you join those points, you are going to have parallel lines of an equal length. Whereas a translation, they are going to be of equal length. So this is the difference that we are going to have in these transformations. So like I said, we are going to focus on a reflection. So we want to consider this reflection on its own as a transformation to say that since we have seen that a reflection, one, it is an isometry. It is part of the isometries where the object and the image are the same. What we see on the object is exactly what we are seeing on the image. It's exactly what is on the image. And if now the points are being joined, you join A to A1, just like the previous case, B to B1, you're going to have parallel lines, but they will be of an equal length. Once you see this, you conclude now that to say this is a reflection. There is no isometry of all the isometries that we have, of all the three isometries that we have. Not one will have parallel lines of an equal length. It's only a reflection. A translation, yes, it has parallel lines, but they are of equal length. So do not confuse between these two. So now that I have seen this, okay, this is a reflection. I have seen that, okay, because of what? These properties. I have to describe, like I said before, on a translation, that to describe a transformation, you must mention that transformation. So now you must describe. So to describe a reflection fully, now you have seen that this transformation that is given there is a reflection. You must describe it. It is a reflection. You are now describing. It is a reflection. You are stating the type of the transformation. You are stating the type of the transformation. It is a reflection. Just like when you saw that it was a translation, you state it is a translation. And what we saw on a translation, there was a translation vector there. On a reflection, there is no reflection vector. No. On a reflection, there is what we call the equation of the mirror line. So you must state or you must determine the equation of the mirror line. So also state here the equation of the mirror line. So these are the two things that you need. The equation of the mirror line. What is the mirror line? That is the question. What is this? The mirror line. The mirror line, it is the line which maps the object to the image. You see a reflection. Just consider exactly what you see on the mirror. You see the mirror. Let's say we place a mirror here. If a mirror is placed at this point, you will see that reflecting yourself to the mirror, into the mirror, the distance that is the closer that you are to the mirror, it is the same concept with your image inside of the mirror. It will be closer to you. The more you move closer, you also see that the image that you are seeing, your image inside the mirror is also moving closer to you. If you are in contact with the mirror, let's say you put your hand on the mirror, you also see that the image of your hand is in contact with you. It is because you are in contact with the mirror. So use that idea of the mirror line, of the mirror, to use it on the mirror line to say that there is a shape here. Okay, let's start with a point. There is a point here, which is A, which is transformed along the mirror line. Transformed along the mirror line, maybe it is the line of X is equal to 0. Remember, the line of X is equal to 0 is our y-axis. Transformed along the y-axis, or the line of X is equal to 0. You are going to see that if A is on this side of the mirror, because this is your mirror here, this is your mirror, this one. So the mirror is dividing our graph into two regions. this side of the mirror and the other side of the mirror. So it's impossible that if A is on this side of the mirror, this is where A is located, then I find the image of A on the same side of the mirror. Guys, there's no magic like that. It cannot exist. There is a mirror here. You are to check yourself on the mirror. Then you are now finding the image just right beside you, not inside of the mirror. That can never happen, does not exist at all. So in actual sense, what I'm trying to say is that if the point A, which is our object, is this side of the mirror, this is the side where it is, therefore its image must be on the other side of the mirror line, across the mirror, along. You have to be on the other side of the mirror line. It must be on the other side. So if this is A, maybe A1 is there, located somewhere there, across. Not to say that point A is here and its image is also this side. No, it won't be like that. It won't be like that. So we are going to talk about that in practice. Okay. The question now is, how am I going to determine the equation of the mirror line? It's a line, so we must determine the equation of a line. So you must refer to your algebraic graphs. So make sure that you go back to your algebraic graphs. The equation of a straight line, remember your algebraic graphs, y is equal to mx plus c concept. Yes, those vertical lines and horizontal lines, you must be able to understand the equations. So I'm not going to talk about that. It's something that we have from our straight line graphs. So make sure that you revise your straight line graphs to determine the equation, because we are talking about equation of a line, the equation of a line. So you must know how to determine the equation of a line given 2 points. How do you determine the equation of a line passing through 2 points? Once you know this, you're done. So that is what I'm simply saying. Please make sure that you revise that so that you will not have a challenge when it comes to finding of the equation of the mirror line. All right, anyways, so this is it. In order for you to determine, so this is to describe. So as you can see, to describe a reflection, we are just going to have 2 marks. A mark to write that it is a reflection and a mark of the equation of the mirror line. So the question now is how to find now this equation. All right, so how am I going to find this to determine? Because I need to determine this, but how am I going to find this? To find the equation of the mirror line. To find the equation of the mirror line. You do not write this when you're asked to describe. To describe, you're done here. This is to describe. Now I'm just saying, since you need this equation of the mirror line, so the first thing is we need to know the mirror line first. How am I going to know the mirror line before finding the equation? So you have joined, remember, you have joined A to A1, B to B1, C to C1. These are the points that you have joined on your diagram, object, and image. So let's take a consideration between just 2 points, A and A1. We have joined these 2 points like this, A and A1. So to find the equation of the mirror line, you are going to bisect this line that you have joined between A and A1. Remember your construction. To bisect, open more than half of the line, you bisect this line. So you are going to bisect this line. By bisecting this line, the line bisector, this one that you are forming, is the equation of the mirror line. That is your mirror line. That one. That is your mirror line. So you must determine its equation. Remember, to determine the equation of a line, you just need 2 points which lies on the line. As long you've got 2 points, you are done. So to determine or to find the equation now, you need 2 points. So you're going to use, so to find the equation, you use 2 points that you are given from there. So the first thing, like I said, what you're going to need to do is to bisect. So you bisect any corresponding combination, any corresponding points joined, any corresponding points joined, because remember you joined those points A to A1. So for an example, A to A1, A to its image, you bisect the line. So the line bisector is the line, the equation, the mirror line. So the line bisector is the mirror line. That is our line bisector. This line bisector that we are seeing is our mirror line. So by knowing that mirror line, what are we going to do? You have to find its equation. Find its equation. Find its equation. So to find the equation, or to determine now the equation, that is when you are going to need any points now, any 2 points on the line. So it depends with the type of a line. Remember those vertical lines, if you are given a vertical line which is passing through the point 3. The equation, I don't need 2 points. I just need to know where it is passing. It's passing through point where x is 3. So the equation of the line is x is equal to 3. Just like the y-axis, x is equal to what? X is equal to 0. So guys, please make sure that you revise your algebra so that we are not going to have a challenge, your algebraic graphs. So the equation will depend with the type of a line. Are you given a slanted line like this? On this type of a line, there you will need 2 points to use to determine the equation. You have to find 2 points which lies on the line. But if you are given a horizontal line or a vertical line, there's no need for the 2 points. All horizontal lines, these are the lines of y is equal to. So if it passes through the point where y is 3, the equation will be y is equal to 3. The x-axis, we know its equation is y is equal to 0. They are not of the form y is equal to mx plus. They're just direct lines. Y is equal to this. So this is what you are going to need on a rotation. So to describe, like I said, these are the 2 major things that you need to describe. All this here is throughout now to finding the determination of what? Of the equation, which is here. So meaning to say it can be maybe 2 marks for that to state the equation, because you need this procedure of determining the equation using the points, this and that. So as you can see, there will be a lot of things. So maybe at the end, to describe a reflection might even end up with 3 marks. No problem. So let us try these questions. Let us just try a few questions. So in each case that we are going to have here, in each case, we are going to describe. In each case, describe. In each case, describe the single transformation. Describe the single transformation. All right, that's our question there. Describe the single transformation which maps triangle ABC, which is the object ABC, onto the image triangle A1, B1, C1. So in each and every case, this is what you're going to do. So we are going to maintain ABC as our object. So we are going to maintain triangle ABC as our object. So triangle ABC, with the vertices A, let us just say A is 1, 1, B 2, 1, and C 1, 3. Okay, let's say these are the coordinates of the triangle ABC. So like I said, ABC is the object, so we are going to maintain this object throughout. So the images are going to change. So we need the transformation which will map ABC onto A1, B1, C1. All right, so let's start with the first image, triangle A1, B1, C1 with the vertices A1. Let's say A1, it's 1 minus 1. Okay, then we move on to B1, which is 2 minus 1, and C1, which is 1 minus 3. Let's say this is what we are given. Let's say this is what we have. Let's start 1, 1. Okay, we're going to move on to another question, but same, we're going to just use the same object. So I've got two triangles, and I need to describe the transformation that will map this triangle to this triangle. All right, so like as usual, you need first your Cartesian plane. So you'll be given a scale 2 centimeters, maybe to represent 2 units or 1 unit. So in this case, we're just gonna use 1 unit on both axes, 2 centimeters to represent 1 unit on both axes. That is the x and what? And the y axis. So that's -1, -2, -3, and so on. -4. -5, and also you're gonna need -6. So make sure that you use the Cartesian plan according to the scale that you're given. All right, 1, 2, 3, 4, 5, and we have got a 6 there. So this is what you're given. We are given the triangle ABC with vertices 1, 1, 2, 1, and so on. All right, so let us have A, that was 1 versus 1, x is 1, A and y is 1. So we mark that. That's our object, A. Then B is a 2, 1, 2 versus 1, 2 versus 1. That's here you mark your point B. Then C is 1 versus 3. X is 1, y is 3. You mark the point. X is 1, y is 3. So this is our point C. With these points, we are going to join so that we formulate now the triangle that we are given, which is our triangle ABC. So this is what we're going to have, triangle ABC. So the question is, we are supposed to describe the transformation that will map this triangle ABC to the image. The image. A1, B1, C1 with A1. These are the coordinates 1 minus 1 and so on. All right, so let us check our coordinates. A1, that is 1 minus 1. 1 minus 1, that is our A1. All right, our B1 was given as 2 minus 1. That's 2 minus 1. That's our B1. And our C1 is given as 1 minus 3. So you're going to mark the coordinates. Then you join the points that you are given. All right, so let's see what we are going to have at the end. So just make sure you draw properly. You join this using your ruler. All right. So with these points that we are seeing, let's just see this one. Sorry for that. Let's just stop. It's not going to affect anything. I just need to remove something here. All right. Sorry for that, guys. Let's hope this can move here. Oh, okay. I'm seeing this. All right, very sorry for that. So it's supposed to be at least straight enough like this. Okay, so this is what you're given. We need to describe the transformation which maps the object A, B, C, this triangle, onto the image A1, B1, C1. Looking into these two, we can see that there's nothing has changed. It's only the position. This is now drawn the other way. But the size of the triangle, it is still the same. From A to B, from this side, this side, this side, same length as it was before. So as we can see, these are isometries. These figures, these two triangles are congruent. Object and image are the same. So we are expecting there to have a translation, a reflection, a rotation. These are the three transformations that we are expecting. But as I said, for a translation, we are going to have parallel lines of equal length. For a reflection, we are going to have parallel lines of unequal length. For a rotation, the lines will cross. So this is what you need to test now. By joining corresponding points, we need to check this by joining the corresponding points. The point of A to A1 using a ruler that must be broken line. A to A1. You do the same thing, B to B1. You join B to B1 from this point B to B1. Okay? Then you do the same thing from C to C1. But on this one, I want you to see what is happening there from the point C. Let me just try to use something so that it can be fine. From the point C, look where C is. To point C1, it's like this. C to C1. C to C1. What are we forming? These lines are parallel. All right. A and A1, this one, C and C1, they are along the same line, guys. It's like this. It's like I'm just giving a line like this. Then this is C, this is C1, this is A, this is A1. It's the same line, only that A starts here and ends here. C is from here to this point, but it is the same line. So we cannot say these two lines, they meet. No, it's just the same line. But considering this line and this line, how are they presented? They are parallel to each other. Guys, these two lines will never meet. That is to mean they maintain same distance. They are parallel to each other. But as they are parallel, what about the length? Are they of equal length? From A to A1, truly it is the same as from B to B1. We've got equal length there. B to B1, A to A1, it is equal length. That is true. But let's check now from C to C1. Just look, the distance that is there. Compare it with the B. There is no need of a ruler there. By sight, by just looking, you can see these two are not of equal length. So it's not about having these two being of equal length. Then as long there's another part there that is of an equal length, it changes everything. If they are of equal length, they are supposed to be of equal length throughout. So this parallel line and this parallel line, they are not of equal length. They are not of equal length. So meaning to say that a translation is out, because on a translation, they are supposed to be parallel and of equal length. So the equal is missing. They are all supposed to be of equal length, not to say A and A1, no. Everything. So if you check C to C1, it's not the same as B to B1. So it makes it to be unequal. So it means at the end, reflection is going to be our answer, where we produce parallel lines of an equal length. Rotation is totally out because the lines, they are supposed to cross. But in this case, as we can see, as you join B to B1, we do not have a condition where the lines are crossing like this. So rotation is totally out. Rotation is totally out. So now that I have seen that this is a reflection, because these are the three answers that I was expecting. One is supposed to be the answer there because they are isometries. The object and the image are the same. So you do not write that, like I said, you do not write that object and the image, they are the same. So I joined this point. No, you don't write that. You describe now. It is the transformation that is presented there, which transformation is it? It is a reflection. That is to describe now. It is a reflection. Then what are we going to need from that? We are going to need the equation of the mirror line. The equation of the mirror line. The equation of the mirror line. What is the equation? So like I said, in order for you to have the equation of the mirror line, you must have the mirror line first. So to have this mirror line, you bisect any corresponding, bisect, construction. We are back to construction. You bisect first. Then after bisecting, you determine the equation, because the line bisector represents what? The equation. So we are going to bisect, meaning to say, to bisect, guys, what is to bisect? To divide the line into two equal parts. To divide into two equal parts. So let us go back to our construction. So in this case, let's say you choose to bisect B and B1. You just choose any combination of your choice. But vertical, okay, let me talk about this, because we need to bisect there. There are some other things that we might waste our time, but still we're going to need that. Talking of vertical lines, if a line is vertical, to bisect is to divide into two. You can even see where the half of the line is. Guys, this is B here. This is B1. The line that we have is this one, that is produced. This is the line. To bisect is to divide this line into two equal parts. So where is going to be the line bisected? Definitely, the line bisector is going to be in the what? In the x-axis, this one. This is our line bisect. To divide this line B to B1 into two equal parts. That is to bisect. So that's what I'm saying to say. Some of the lines, like a horizontal line, a vertical line like this one, there's no need for you to bisect. You can even see it by sight. But in actual sense, you're supposed to bisect like this. All right, let's bisect. Remember, to bisect from our construction, you have to step the middle point at point B. So like you choose which one. Do you want A to A1, B to B1, or that C to C1? So I'm just going to take B to B1. You open more than half of the line. As you can see, this is more than half of the line. So remember, on your bisection, you construct. So you are going to mark an arc along this side. You mark an arc. You do the same on the other side here. All right. Sorry for that. You see now these things. All right. So I needed this side, this thing, guys. Why is it just misbehaving like this? All right. Let me just restart everything. Let me just restart everything here on this one. I'm just gonna restart here. All right, so I'm just gonna open another half because now it affected me. Let me do it like this. All right, so this is what you're gonna need here. You just open more than half of the line like this one. It's more than half of the line. You construct an arc this side. All right, let's say this is the arc. You do the same thing on this side. All right, just gonna move on to this side, construct an arc like this. All right, you move on to this side to B1. Remember, it's B and B1, B and B1. In this case, I'm using B to B1. I'm going to bisect B to B1, bisect. You choose maybe A to A1, it's your choice. So in this case, I chose B and B1. So now I am at the point B1 without changing the length. Remember, to bisect, you do not change the length that you have used before. Without changing this length, you're supposed to mark an arc this side, and also on the other hand here, you mark an arc. Remember the idea that these two, where they meet, the bisectors, they meet here. Where they meet, we are supposed to draw a line joining the bisectors. As we can see, guys, drawing a line passing through these bisectors, we are simply having a repetition of the repetition of the x-axis. This line passes through the x-axis, as we can see. All right, guys, what is happening here? This one. It is a repetition of the x-axis. The line passes through the x-axis as we are to draw our line bisector. It passes exactly through as we join this point to this point using the line. It's the x-axis. So that is your equation of the mirror. The equation of the mirror line. This is our mirror line. The line bisector. I said the line bisector. After bisecting, what is it that we have? The line bisector. The line bisector is the mirror line. Find its equation. So the mirror line that we are seeing here, this mirror line that we have drawn, this line bisector that we have drawn, this one, which is our x-axis, that's our line bisector. That's our line bisector. So that is your mirror line in actual sense. So if it is the mirror line, what is the equation of this line? This is the x-axis. What is the equation of the x-axis? In the x-axis, we know that the equation of this line is y is equal to 0. So the equation of the mirror line, thus y is equal to 0, or along the x-axis. This is y is equal to 0. So that is to describe a reflection fully. It is a reflection, then you state the equation of the mirror line. You state the equation of the mirror line. All right, let us have another question. Let us have another triangle. So I want us to use the same object, ABC, this one. Let us use the same object. So this time we are going to use the other image. All right, so this one was triangle A1 and so forth. So let's have triangle A2, B2, C2 with the vertices. Let's just say A2 is given as -3, 1, -3, 1, B2, -4, -4, 1, and C2 is given as -3, 3. Let's say these are the coordinates that you are given and you're asked to describe. You are asked to describe. Remember, our question there is still to describe in each case. Remember our question. In each case, describe the single transformation which maps triangle ABC onto this triangle. All right, but now we have got A2, B2, and so on. All right. So the first thing is to draw this triangle. All right. Let's draw our triangle. That's gonna draw a triangle. A1 is given as -3, 1, -3, 1. You mark your point here, -3 versus 1. That is our point A1. Okay. Then B1, -4, 1, -4, 1. You mark your point. This is B1. C1, -3, 3, -3 versus 3 like this. You mark your point. This is your C1. So you have to join to complete your triangle. All right, so let us join this so that we've got our completed figure like that. So the question is to describe the single transformation. All right, so remember this is now 2 and B2, A2, C2. All right. So the question is to describe the single transformation, which means this object, we are still on the same object that we had before, A, B, C, this one. Don't consider this. There we're done. We described this one, we're done. So let's say it's another question that you're just working on. So we want to know the transformation which is going to map this triangle onto this triangle. The object ABC and the image A2, B2, C2 are exactly the same in terms of the size that we're having there. Meaning to say, we still have to go through the process. Is it a translation? Is it a reflection? Is it a rotation? Translation, parallel lines, of equal length. Reflection, parallel lines of unequal length, like I said before. Rotation, the lines they do cross. So we have to do the same procedure as previously. So let us join. Just gonna join from A to A2, from B to B2, from C to C2, like this. Okay, that is from C to C2, like this. You join your points. So by just looking here for a similar consideration like what we had before, the lines, they do not meet their parallel, but the distance are not the same. Look, from C to C2, C to C2. Then consider from B to B2. Just consider this distance. They are not the same. So it means translation is out, rotation is out. We are just left with the reflection. It is the one which produces parallel lines of unequal length. So once we see that these lines that are being produced there, the lines that we have produced or the lines that we have on our diagram, they are parallel, but they are of unequal length. Therefore, you describe. So this one we are describing triangle ABC to triangle A2, B2, C2. So now we are describing, as we can see, it is a reflection. So that's the transformation. It is a reflection. Then what do we need again? We need the equation of the mirror line. The equation of the mirror line. So the equation of the mirror line, like I said, considering a horizontal line, just like a vertical line, we can even see where the half is. Like if you move from C2 to this point, you move 1. From C to this point, you move 1. As you can see, we are going to meet here at this point, where x is equal to what? Where x is equal to -1. But if you do not know that, therefore you have to bisect. To determine this equation, or to have the equation at the end, you must bisect any corresponding pair. A to A2 is up to you, or is it B to B2? It's up to you. C to C2 is up to you. So in this case, I'm going to bisect C to C2. Just like the previous case of our bisecting, we are going to need our compass to do that. So let's just see. So this is it. With the compass, you have the needle point. You can gonna start it at C. It's up to you, or at this side of C2. So with this more than half of the line, you are going to mark or construct an arc on top. Then you do the same thing, an arc down. Remember, guys, you need to bisect the same way that you bisect your lines in your normal constructions. All right, then you move on to the point C2. With the needle point at C2, we are going to do the same thing, construct an arc on the top. Then we do the same thing, construct an arc down here. So by doing this, we have to join now from the points of intersection of these arcs. They intersected here. These ones, sorry, slight bit, it was supposed to intersect somewhere here. Sorry for that. It's just because of the slight movement. It can happen like that. Then learn also to correct yourself in exam to see, no, this cannot be a line like it cannot be something like this. Then just a line part, it must be a vertical line. So you join these lines, these points that we are seeing, which is from this point, all right? So as you can see, the line was going to pass through like this. This is our line bisector. This is our mirror line. The line bisector, which is our mirror line. So there we are talking about the mirror line. What is the equation of this line? The equation of every vertical line is direct. In the y-axis, we know the equation is x is equal to 0 because it passed through where x is a 0. This line, it passes where x is minus 1. So the equation of this line is x is equal to minus 1. It's not of the format y is equal to mx. No, no, no. So this equation, that's the equation of the mirror line. X is equal to what? X is equal to minus 1. That's why I was saying, please do revise your algebraic graphs. We are not supposed to talk about the equation of the line in this class. We are supposed to talk about how to transform this to another point, this to another point. So as we can see that in each and every case that we are going to have, it's either we are going to have this condition where the mirror line is along the horizontal, y is equal to 0, or maybe it was y is equal to minus 2, y is equal to 1, or it can be a vertical. A mirror line can be vertical like this. X is equal to 1, x is equal to 0, x is equal to 3, x is equal to 4, depending with where the mirror line is passing through. But that's not the only type of the mirror line that you're supposed to expect. We can have a mirror line slanted like this. So these are the typical questions that we are going to have in our next class. But for now, I want you to try this question with the same object, A, B, C, but this time our image as, so I want you to describe this. So what you're going to do is to do this question, then you are going to give me a feedback on this one. So this is triangle A3, B3, C3. On the comment section, make sure that you write the transformation and also the equation of the mirror line. So A3 has got coordinates 1 minus 1. All right, we did this one of 1 minus 1. Let me check. We did this one. So let's use minus 1, 1. Minus 1, 1. Then B3, minus 2, 1. Minus 2, 1. And C3, minus 1, 3. Minus 1, 3, like this. All right. So let's say this is your triangle, which is the image. So what I want you to do is to describe the single transformation which maps A, B, C, this object onto this image, triangle, A3, B3, C3. So can you try to do this question? You draw your object, your triangle A, B, C, then you draw your image, triangle A3, B3, C3. Then you describe the transformation. What is it that you are seeing there? Describe the single transformation fully. All right, so you're going to meet in the next class, having a continuation still on this reflection.